Okay, transformation means we're going to change the graph. The first kind of transformation we're going to do is a translation. Translation is like a subcategory under transformation. Translation is a type of transformation, and that is moving the graph up or down and or left or right. We're not changing the size of the graph. We're not switching whether it's pointing up or down. We're just moving it up or down, left or right, moving the whole graph. Well, what whole graph am I talking about moving? And so that would be the parent graph that I'm talking about moving. And we have actually learned 2 parent graphs, and we're going to add a third one. And so the parent graphs that I am looking at, where are my parent graphs? Get all the way up here. The first parent graph that we're going to look at, or have looked at already, is called a quadratic parent graph. Now, you don't have to try to copy this down because this PDF document is in your Schoology folder in the Monday lessons. And so, do you remember looking at this graph before? The quadratic graph has this equation. It's the simplest of all quadratics. If you plug points into the equation, you can make a table, and then we made the table into a U-shaped graph. This is a new parent graph because just last week we were talking about solving square root equations. And this is the graph that goes with solving square root equations. And so I got this graph by plugging in points into this graph. Why don't we have any negative x values? What happens if we plug in negative x values? Do you remember that negative x values is how we get imaginary numbers? We do not want imaginary numbers on this graph, and so we do not have any negative x values. And do you see that this makes a curve? Oh, by the way, back on this one, what's the vertex of this quadratic parent graph? 0, 0. What's the vertex of this parent graph? 0, 0. And way back in the first 6 weeks, you did an absolute value parent graph. An absolute value parent graph has a V shape because the absolute value changes these negative numbers into positive numbers. And what is the vertex of this graph? And so we are going to be taking the quadratic and the square root and the absolute value and a generic function and moving it right and left and up and down. And so let's see how that's going to work. So our first example is g of x equals x minus 5 squared plus 3. Often we use g of x to represent a graph that has been transformed. Now, first of all, what is the name of this graph because of the squared? This would be a quadratic graph because the x is squared. What shape is it going to have? It's going to be a parabola. Now, the parent graph has a vertex at 0, 0. This, do you recognize this as vertex form? So where would the vertex of this graph be? because we remember that this is -5, the vertex is +5 because x is a liar, right? So if we start out with the vertex at 0, 0, and we move the whole graph, including the vertex to 5, 3, which way did we move the graph? Right 5 and also up 3. That is the translations represented by this graph. Example number 2. What is the name of the graph that has these symbols in it? And absolute value has what kind of graph? V in value makes a V-shaped graph. Using the same kind of rules that we did up here, the vertex of our absolute value graph will be the 4 and the 1, and this one that is in the absolute value with the x, x is a liar, so it changes signs, and this one doesn't. And so the translation represented by this g of x equation is +4 and up 1. Oops, I'm off the bottom of my screen. Example number 3. This symbol is square root. What does the square root graph look like? What is the vertex of this square root represented by g of x? Because x is a liar and the other number is not. Now, if the square root started out at 0, 0, and the vertex and all the rest of the graph moved this way, which way did it move? Three, 4. So we have g of x equals x minus 1 squared minus 5. What's the name? Since it is squared, it would be a quadratic. Quadratics have this U shape. What is the vertex? X is a liar. This one is not. Compared to the parent graph, what is the translation? Right 1, down 5. G of x is x plus 2 minus 3. These absolute value bars means that it is an absolute value graph. The V in value tells me the shape. It's a V-shaped graph. And the vertex is the 2 is with the X is a liar, this one is not. And so the translation is negative, so that would be left 2, down 3. What is the name of this graph? His name is square root. His shape is something like that. The translation, it is often helpful to write down the vertex before the translation. It's not totally necessary. But instead of the vertex being at -6, it would be at +6 and +5. So the translation would be right 6, up 5. This graph, compared to the parent graph, would be right 6 and up 5. What does this mean? It means I have a generic graph. This F stands for any graph that is a function. So whatever the graph is, what is this going to tell me about how it's going to move? X minus 10 means it's going to go right 10, because X is a liar. Instead of going in the negative direction, it would go in the positive direction. So you can do the same translations with a generic graph. You don't specifically know which graph it is, but any graph is going to operate in the same manner as our parent graphs. So next, I have some graphs for you to look at. So I have not an equation this time to look at, but a graph. This one that is dotted is the parent graph, and this one is the transformed graph. So the vertex of this transformed graph is at -2, -4. You can just look up here. You can make a sketch of it if you want to, or you can just look up here. So what's the equation going to look like? What kind of graph is this? It's an absolute value, so it's going to have an absolute value sign. What's going to go inside this absolute value sign? X plus 2, because this is a liar, so if this is -2, it's going to say +2. And then the -4 is going to be at the end. Do you see how it has arrows on both sides, the left side and the right side? That means that the domain is going to be all real numbers. The range, do you remember that the range goes in the y direction? Well, obviously the arrows are pointing up, but does it go down or does it have a bottom point? It has a bottom point right here. What is the y value right here? And so y is greater than or equal to -4. What kind of graph is this? It's a quadratic. This is the parent graph. This is the translated graph. The vertex of this translated graph is at 5 and -3. What is the equation going to look like? Well, what does a quadratic equation have in it? Squared. And so what's going to be in the parentheses? And then -3. The arrows on the end tell me that it's all real numbers. But it has a bottom point. The y value of this bottom point is -3. Y is going to be greater than or equal to -3. I have one more. What is the name of this graph? Square root. And so it's supposed to have arrows on the end. And the vertex here would be at -4, -5. So if it's a square root graph, it's going to have a square root in the equation. What's going to go under here? And then make sure that you have the -5 is outside of the square root sign. Now, this one does not have arrows on both ends. The x is going in the positive direction. It's getting bigger. And the y is getting bigger. It's going up and it's going to the right. So both of those are getting bigger. Where did I get these two numbers? They're the vertex numbers. Does that make sense? Is this fairly easy? Just a second. Let me get this turned off, and then I can't get it turned off. I can't find my mouse.